Our sixth lecture video on fluids will cover fluid flow. There are a couple different types of fluid flows that you can encounter. Streamline flow, also called laminar flow, is the smooth flow of a fluid through a pipe or tube. In this picture, you can follow the arrows or streamlines and see that they're all pointing in a straight line. The other type of flow is turbulent flow or non-laminar flow. This is the erratic, unpredictable flow of a fluid resulting from excessive speed of the flow or from a sudden change in the size or direction of the tube. In this first picture, there is an object that the fluid encounters. Upstream from the object, the flow is laminar, but downstream from the object, there's turbulent flow, meaning that the fluid is moving in all sorts of random directions. In the second picture, if the flow is too fast, you will have turbulent flow, represented by the arrows pointing in every direction. In the third picture, the fluid encounters a bend or fitting in the tube. Upstream from the bend or fitting, the flow is laminar, but downstream there is turbulent flow. When we are talking about fluid flow, we are going to assume it is streamlined so we can calculate the flow rate. The flow rate of a fluid is the volume of the fluid flowing past a given point in a pipe or tube per unit time. To find the flow rate, represented by a capital Q, we will take V, the speed of the fluid through the pipe, and multiply by capital A, the cross-sectional area of the pipe. Another way to imagine this is, let's assume we have streamlined flow through a straight section of a pipe at speed V. During time interval t, each particle of fluid travels a distance v times t. If A is the cross-sectional area of the pipe, the volume of the fluid passing a given point during the time interval is v times t times A divided by t, which, because the t's cancel out, is why we are left with v times A in this equation for flow rate. Let's take a look at a flow rate calculation. Water flows through a garden hose of diameter 1.60 centimeters at a speed of 5.35 meters per second. Find the flow rate of the hose in liters per minute. First, we will write down all of the data we were given in the problem. The velocity of the water is 5.35 meters per second. The diameter of the hose is 1.60 centimeters. However, when we calculate flow rate, we need the area, so the cross-sectional area of a circle is pi times the radius squared. The radius will be half of the diameter, or 0.800 centimeters. We will take pi times 0.800 centimeters squared to get a cross-sectional area of 2.01 square centimeters. However, because the velocity is in meters per second, we need our area to also be in square meters. To convert square centimeters to square meters, we will divide by 100 times 100, or 10,000. This gives us an area of 0.000201 square meters. We are trying to find Q, the flow rate. Now that we have the correct area, the basic equation that we need is that Q, the flow rate, equals the velocity times the area. Since this is already written in terms of Q, we can go directly to the substitution step. Q equals 5.35 meters per second times 0.000201 square meters. This gives us a flow rate of 0.00108 cubic meters per second. However, the problem asks for the flow rate in liters per minute, so we have to do a few unit conversions. We can take 0.00108 cubic meters per second and multiply by the conversion factor 1,000 liters equals 1 cubic meter. We will also multiply by the conversion factor that there are 60 seconds in 1 minute. This gives us a flow rate of 64.5 liters per minute. This concludes our discussion of flow rate.